Hello everyone. In this video, we are going to look at another problem which is available on LeetCode. The link to this problem will be in the description of this video. And the problem states best time to buy and sell the stock. So we are given an array, prices, uh, and it has basically the price of a given stock on ith day. Okay. We want to maximize the profit by choosing a single day to buy and another day to sell the stock, and we need to select the days to buy and sell the stock in such a way that our profit is maximum and we need to return the maximum profit. Okay, great. So it's simple. So let's just discuss the idea behind the problem. So consider this is the array which is given to us. So let's first discuss the regular regular approach. Okay. So what does the regular approach states? Very simple. Um, we need to basically select a day to buy the stock and then a day to sell the stock, and the profit should be maximum. Okay, so what we will do is in this regular approach we will use two loops. Okay, so I and j, two loops. So loop I to select uh, for buying, let's say, and then inner loop j to select for selling. Okay, and then let's calculate profit. Okay, it's simple. Okay, so what we will do is we will initialize a variable called as int max profit is equal to 0. Okay, we will initialize this. Okay, and then what we will do is um this is low outer loop I. So this is outer loop, and so consider I will start from here, and definitely j need to start from I plus 1. Okay, definitely j, because if I'm buying on this day, okay, if I'm buying on this day, then I cannot sell on this day. Okay, then I cannot sell on this day. Okay, so I am buying on this day 7. So 7 minus 1, so I'm buying on 7 and selling on 1. Okay, so profit will be what? So profit is equal to ARR of J minus ARR of I. Why? Because we are selling on this and buying on this. So selling minus buying is equal to profit. Okay. So 1 minus 7 minus 6. It's a terrible loss. We cannot do that. Then 5 minus, then a j plus plus 5 minus 7 minus 2, terrible loss. Okay, 3 minus 7, 3 minus 7 minus 4, terrible loss. 6 minus 7 minus 1, terrible loss. 4 minus 7, it's a loss, minus 3. Then what we'll do is I plus plus, and again j will start 1 after I. Okay, so j will start from I plus 1. Why? Because we can sell only after we buy. Okay, so if I am buying on I, then I can sell anytime after I. Okay, so I have bought on 1 and I am selling on 5. So 5 minus 1, 4. Okay, so profit becomes 4. Okay, and now we will compare it with max profit. So max profit is 0. 0 is less than profit, so max profit becomes 4. Now we will take j plus plus. So 3 minus 1, 2. profit becomes 2, but still it is less than max profit, so max profit still remains 4. Okay, then j plus plus 6, 6 minus 1 5. Okay, so profit becomes 5. Now max profit is less than, so update profit, max profit becomes 5. Then again sell on 4, 4 minus 1 3, but max profit is 5 5, so we'll not update max profit, and profit will remain 3. Okay, and now again I plus plus, and j will start from I plus 1. Okay, so we are buying on 5 and then selling on 3. Profit becomes minus 2, terrible loss. We cannot do this, max profit still remains 5. Then 6 minus 5. Okay, we are having a profit of 1, but max profit is still 5, so we will not update max profit. 4, 4 minus 5 minus 1, again loss, max profit still remains. Okay, similarly this I will keep on updating. J will start from I plus 1, and 6 minus 3 is 3. Okay, but still max profit is 5, so we will not update max profit. Then 4 minus 3 1, again max profit is 5, we cannot update max profit. Then similarly I plus plus, and j will start from 4, 4 minus 6 minus 2, terrible loss, max profit will remain 5, and so at the end we will return 5. Okay, so I hope this two loop approach is clear to you. ठीक है, तो loop I for buying, loop J for selling. I have shown you the dry run, and one thing to remember is J will always start from I plus 1. And let's now code this. Okay, let's now code this. Okay, so int max profit is equal to 0. Okay, so for int I is equal to 0, I less than prices dot length I plus plus. Then for int j is equal to I plus 1, j less than prices dot length, and then j plus plus. Then what? We will calculate profit. Int profit is equal to prices of j minus prices of I. Perfect. And comparison, if profit is greater than max profit, then max profit is equal to profit. Simple. And then at the end we will return max profit. Okay. Perfect. Our both the test cases have been accepted, but the time complexity of this solution is O of n square, and O of n square becomes quite costly for large arrays. So in in kind of these small arrays, O of n square is okay, but when it comes to large arrays, O of n square becomes quite costly. So if even if I try to submit it, I think it should give time limit exceeded error. Or okay, so yeah, okay, so however, we can see that 203 out of 211 test cases have been passed. But for, see, look at this, such a large input of array. Okay, so for these large arrays, this n square approach is not good. Okay, so let's just reset our code. Okay, and um, so what we will do is we will now further look on how to optimize our how to optimize our code. Okay, so it's simple. Time complexity in this case would be O of n square, and space complexity would be O of 1. Okay, but we can still optimize it. So optimized approach. So what is expected time complexity in optimized approach? Expected time complexity is O of n, and space complexity is O of 1. Okay, so let's see what we can do. So um, what we will do is, um, we will declare a variable initially which is int minimum so far. Okay, minimum so far, which is equal to ARR of 0, first location of our array. Okay, so minimum so far will be equal to ARR of 0. Okay, and what we will do is, we will use a single loop. Okay, so we will use a single loop. Okay, and in that, step 1, okay, step 1 would be if ARR of I is less than min so far, then update min so far, means minimum so far is equal to ARR of I. Okay, then step 2 would be what? um, profit profit is equal to ARR of I minus min so far. Okay, and step 3 would be if profit is greater than max profit, then max profit is equal to profit. Okay, so these are the simple steps. Okay, so minimum so far will be initially error of I, error of 0. First element is nothing but first element of array, and then we will find profit, update maximum profit, and we will keep on doing this. Okay. So let's say minimum so far is denoted by letter M. Okay, so minimum so far is denoted by letter M, and okay, so let's see what we can do. And so this is I, and this is minimum so far. Okay, this is minimum so far. Okay, so initially minimum so far is first element, and this is I. So and approach, and what will how will be profit? Profit is ARR of I minus minimum so far. Okay, ARR of I minus minimum so far. Okay, so this will be equal to, now in this case, minimum so far is M, and I is at first place. So we will check if ARR of I is less than minimum so far. 7 is not less than 7, so minimum so far will remain 7. 7 minus 7, profit is 0. Max profit will not get updated. Okay, next, I plus plus. So now I is 1. Now we check if ARR of I is less than minimum so far. Yes. Why? Because minimum so far is initially 7, and now 7 is less than 1. So now minimum so far becomes 1. We update this. Okay, and um, so minimum so far is now this, and what we will do is we find profit. Profit is ARR of I minus minimum so far. Okay, so ARR of I minus minimum so far. So still 1 minus 1 0. mm, profit is 0, max profit also remains 0. Okay, now I plus plus, great, I plus plus. Now 5. Now we check if ARR of I, that is 5 is less than minimum so far. No, it is not less than, so minimum so far still remains, minimum so far still remains 1. Okay, so now let's calculate profit. So profit is now what? 5 minus 1. So profit now becomes 4, and 4 is greater than max profit, so max profit becomes 4. Okay, now I plus plus 3. So let's see if 3 is less than minimum so far. No, 3 is not less than minimum so far. So minimum so far still remains 1. Now profit 3 minus 1, 2. So 2 is not greater than maximum profit. So maximum profit will still remain 4. I plus plus. So 6. Is 6 less than minimum so far? No, 6 is not less than minimum so far. So minimum so far remains 1. And profit is calculated as 6 minus 1, which becomes 5. Okay, so profit is updated, it becomes, maximum profit becomes 5. Then I plus plus. So is ARR of I less than minimum so far? No, so minimum so far is not updated, and minimum so far remains 1. So 4 minus 1, 3. Okay, but we have already got maximum profit as 5, so maximum profit will not be updated. Simple. So maximum profit is 5. Our answer is 5. Now even if you see the array, and what you observe is, if you buy on 1 and sell on 6, you get maximum profit. There is no other scenario. You could try all other possible cases, but you cannot do. Why? Because see, on 7 if you buy, see, you cannot do like this, like buy on 1 and then sell on 7, because 1 comes after 7. So if first you have to buy, then you have to sell. If you have bought on this, you cannot go back and then sell on this. Okay, so it's simple. You have to buy on 1 and sell on 6. This is the only case for maximum profit. Okay, and so this was about the dry run. Now let's see if we are able to write the code. So int min so far is equal to prices of 0. Okay, good. Means prices of 0, first element. Int max profit is equal to 0. Good. Then for int I is equal to 0, I less than prices dot length, I plus plus. And then what? If prices of I is less than min so far, oh sorry, min so far, then min so far is equal to prices of I. Okay, then int profit is equal to prices of I minus min so far. And lastly, if profit is greater than max profit, then max profit is equal to profit, basically updating the profit, and then at the end we will return max profit. Simple. mm, Nothing tough as such. So it's simple, we have followed all our simple steps. So what was the simple step? Single loop I from 0 to length. Step 1, if ARR of I less than min so far, then update minimum so far. Calculate profit, which is ARR of I minus minimum so far. If profit is greater than maximum profit, then update maximum profit. As simple as that. Okay, let's see if it is working or we are getting any errors. Okay, Let's try to submit it now. Oh yes, it got accepted. Great. So see, it's a good approach, and the time complexity in this case was O of n, and space complexity was O of 1. Okay, so I hope you were able to understand both of these logics. Okay, so initial was the regular one, which time complexity of n square, outer loop for buying, inner loop for selling. However, in the second, we used a slightly tricky approach. We declared a variable minimum so far, and then we kept on updating it, and we calculated profit. We then updated we then updated maximum profit accordingly. Okay. So thank you everyone. If you think I was able to contribute in your logic building, do like and subscribe, and I will keep on posting such videos because my only motive is to contribute to logic building. So thank you everyone and see you in the next video.